we are going to deal with quadratic equations. We're going to look at three ways of solving them. Okay? One way is solving by factoring, and one way is solving in the calculator, and then the book goes over 2 ways of solving in the calculator. We'll probably just go over one. Okay? So that's what we're doing with quadratic equations. We're solving, which means we should know what solve means. Because when I give you a quadratic equation, it may be in the form y equals ax squared plus bx plus c. Okay? So something like y equals x squared plus 5x plus 6. If I ask you to solve that, what are you supposed to do? If you're given this equation, solve means set it equal to 0 and solve for x. Okay, that's the algebraic definition. If I ask you to solve a quadratic, it means take x squared plus 5x plus 6, set it equal to 0. Solve for x, which you could solve by factoring or any number of other methods. So graphically, what does that mean? If you think about the parabola, when we set it equal to 0 and solve, what are we finding? Graphically, this is where the graph hits the x-axis. What are the solutions of the quadratic equation x squared plus 3x minus 18 equals 0? So we said solving a quadratic, finding the solutions is when it's set equal to 0. This one is. So this one should factor nicely. We're going to solve this one by factoring. So looking at x squared plus 3x minus 18, how does it factor? Yeah. What two numbers multiply to negative 18 and add to 3? So it factors as x plus 6 times x minus 3. That still equals 0 because this is equivalent to this. So if this equals 0, this equals 0. So now we have to use the zero product property, which states if you have two things, here's 1, here's 2, two things multiplied together and the result is 0, then one of them has to be 0. And it doesn't make a difference which one it is. So we could have x plus 6 equals 0, in which case x is negative 6, or we could have x minus 3 equals 0, in which case x is 3. So what are the solutions of the quadratic equation? X equals negative 6 or x equals 3. We are asked for the solutions of the quadratic equation 10x squared plus 2x minus 46 equals x minus 4. Right, what we have to do first is get it set equal to 0. So we have 10x squared plus x minus 42 equals 0. I'll tell you that I'm fairly certain this one does not factor nicely. And so what we're going to do instead is we're going to use the calculator to solve this. Okay, we're going to graph this one. So you go into y equals, make sure everything's empty, and you're going to put in that equation that I had written down right there. 10x squared plus x minus 42. We want to graph this. If I do zoom 6, if I do the standard zoom window, that's what it looks like. Is that enough to get the solutions to my quadratic equation? So this window is suitable to find the solutions there and there. Those two, where it crosses the x-axis. So second, calculate. We want to find the 0. Okay, solutions will be referred to as zeros sometimes because it's when the equation equals 0. So let's start by finding this one. So we are asked for a left bound. You just need to move your cursor to the left until the cursor is to the left of the 0. Okay? And if you can't find the cursor, you can look down here at the bottom of the screen. It tells you what point the cursor is at, so you know if you need to move to the left or to the right. Once your cursor is on the left of the 0, push enter, then go back to the right. So now my cursor is down here. Push enter, and then push enter again.
Wait, what button was this?
You use the right arrow to move it to the right. And so talking about left, right is a little bit complicated because the graph is also moving up and down, but you need to focus primarily on left and right. So I found the 0, x equals negative 2.1. And if you do that to find the other 0, you should get that the other one is x equals 2. So what are the solutions? Negative 2.1, positive 2. So again, to solve, the first thing you have to do is get it set equal to 0. Then use the calculator to solve. I want you all to do that on your own and find the zeros. When you do this, the answers you should get: x equals negative 0.4 or x equals 4. The first step in solving a word problem is to read the problem. So take a few seconds to read this. Okay, you've all had a chance to read it. The second step is to define the variables, which here they've done that for us. Then we want to write the corresponding equation, which they've already given us the function. So they've done the first few steps for us here. It's just a matter of reading through and understanding it. Part A, how far does the ball travel before hitting the ground? How do we find that? F of x gives what? Gives height. X gives distance from where it's hit. So in part A, we want to focus on f of x. What should f of x be in part A? F of x should equal 0 because they're asking about when it hits the ground. What is the height of the ball when it hits the ground? 0. So we need to solve for when f of x is 0. F of x is negative 0.002x squared plus 0.77x. Use your calculator, find that 0. So to graph this, you need to adjust your window. What I ended up using, x's go from 0 to 500 and the y's go from negative 5 to 150. It's not a perfect window, but in what I was doing, that's what I ended up using. You graph it and you see that this is a parabola. We need to find this 0. So second, calculate 0. There's my cursor now. So we are to the left of what we want. Then we move down to the right. And you don't need to be able to see the cursor, you just need to know that the cursor is down here somewhere to the right of the 0. Then push enter again. And we can see that our 0 is 385. So in part A, how far does the ball travel before hitting the ground? 385 feet. In part B, how high does the ball go? We are looking for the maximum of f of x, which occurs at the vertex, which we could use our formulas, or, since we already have this in the calculator, we can use that. So what we're looking for is the maximum right here. Second, calculate maximum. We want to move our cursor, la-di-da-di-da, move it until it's to the left of where we think the maximum is, move it until it's to the right of where we think the maximum is, then push enter. So what is my maximum height? So we are looking for, and in the vertex we are looking for the y part, and in the calculator when we do that we find that the maximum height is 74.1 feet. Part C, the domain should be 0 to 385. So domain is 0 to 385 because that's the distance that the ball travels before it hits the ground. What about range? 0 to 74.1. The minimum height of the ball is going to be 0 because, again, the minimum height is when it's on the ground. And the maximum height we found was going to be 74.1. That is a reasonable domain and a reasonable range for our function.